Okay, let's start with the disclaimer first. Hello, let's talk a little bit about the Git and Gerrit. I will try to cover basic topics first, so it is introduction into Git and the recommendation about this amazing book. Then about Gerrit, I will talk a little bit. Then what is the difference between Git repo and Gerrit repo? What is the change in Gerrit? What is the Patchset? What is the difference between pull request and change in Gerrit? A voting system, what is the +2, +1, and etc. What is the work in progress, private change, maybe some REST API information, and so on. To be able to demonstrate the Gerrit functionality, how to work with it, and also later on to show the CI/CD pipeline example connected to the Gerrit, I have written the simple Docker Compose file based on the internet findings, let's say. And inside this Docker Compose file, I declared 3 services. To be honest, I would keep just 2 of them. It is a simple Docker Compose file, and it is needed to be able to run, for example, 2 or 3 Docker containers. So it means that we will have 2 or 3 isolated environments running, and inside them we will have only one Gerrit. Then we have Jenkins master node in an isolated environment as well. And there is the third one, the SSH agent, and to be honest, I have no idea what is it. As you can see, I am using official Docker images provided from Gerrit, from Jenkins. As you can see here, we have added volumes. Under volumes, it means that Docker daemon will create a folder, name it, for example, git volume somehow, and then we'll link that folder towards the Docker container. So container will have an access to physical folder on our hardware. What it means, when we stop the container, the data on that volume, git volume, or that folder that we mounted, will be persistent across the restarts of the container. So we mounting 3 folders for Gerrit. It is for Git, for index, for caching. And then we mount 1 folder for Jenkins to be able to store information about configured jobs, for example, nodes, credentials, etc. So we have somewhere created 4 folders which are mapped to this path inside the container. I will repeat myself. These 4 volumes, they are folders created somewhere on the host system, and they are forwarded to a container to be able to persist data across the restarting of the containers. Another interesting part here is the keyword ports. Here I am opening ports or forwarding ports from the container to host system. So it means I want to open a port from Docker container to my host system. I do it for the SSH configuration and also for the web interface. It is quite interesting because I will use HTTP localhost web address in the web browser. It is just because I am opening these ports. They are mapped to the container. Then I am opening the environment variables to propagate inside the Docker container. And interesting part, it is related to the deploy and resources, when we are saying that I want to limit the resources provided for the container to only 1 CPU core and only 1 GB memory RAM. We still have the whole hardware, let's say, available for the containers, but it is one of the coolest things for the Docker container that you can limit the resources for the container. And you can say that I would like to use 2 cores, 5 cores, maybe 1 core, but you want to get some percentage of the CPU for that core. And then for the memory, you can limit it to, maybe up to 1 megabyte if needed to simulate something. So it is quite cool functionality. And Docker Compose, it is integrated tool inside the Docker package, and it is created to be able to orchestrate multiple Docker containers and volumes and networks, for example, in one file. So you don't need to write any scripts for it. You don't need to do it manually. What you are doing, you define it in the comfortable YAML file according to the reference provided on the web page, and then you use a simple commands, for example, Docker Compose up, Docker Compose down, and they are working. First of all, I would strongly recommend to read this book, which is called Pro Git. You can find it on the official website for the Git. You can find it on different languages, as you can see here on the left. And you can download either PDF or you can download EPUB for electronic books if you have one. It is written by human for human. It is written with some clarifications, with good examples, with illustrations. It is free to download and read. And it is not that, well, it is quite big now, it is 500 pages, but I would say that most interesting parts here is about Git basics, Git branching, for example, Git in server. You can read some of them, it is not that big, it is maybe up to 100 pages, but they are quite interesting to read. And here probably you will find more interesting part, for example, how it is working under the hood, for example, what mechanisms are there. Is it possible, for example, to get a commit which was lost during the branching, and etc. So many cool stuff are described here, and I would say it is not exactly needed to read from top to bottom. You can always start from one of the chapters, I believe. And worst case, you will need to read one chapter before, but it will be mentioned in the text. Another thing that I would strongly recommend also to Google is Gerrit User Guide or Gerrit Walkthrough. Here it is described, for example, step by step, how to make a change, create a review, reviewing, the reworking, verifying, submitting the change. And here it is describing step by step, and I will refer to it as well. So what is the Git repo and Gerrit repo? If we are talking about the local Git repository that you have on your laptop or on your machine, they are the same, they are identical, except the commit message hook. That's only one thing is different, I would say. They still have the same commits, they still have the same branches. The difference will be only inside the Git commit messages. You will have also specific line which is called change ID. So let's take a look at the Git repository first. Then I will try to show you how it works with Git remote repository, and then what is the difference between remote repository and remote Gerrit repository, because the main difference are in our way of working with Gerrit towards remote repository. So imagine that we have an empty Git repo. We just created it either in the same Gerrit, we created it in GitHub, we created it locally, it doesn't matter. And imagine that we have init commit empty, we doesn't have anything. So in our case, we have, for example, main or master branch, depending on the, configuration of your repository. Sometimes you might see that we have master branch as a default branch. Sometimes you might see that it is main branch. And it is because community has decided that master sounds a little bit offensive, and instead of the master branch we should use more neutral name, so it will be main branch. And I would like to intentionally pay attention to this naming, because you might see a situation when you would have multi-repository project. So I mean you have a project with multiple repos up to 1,000, up to 3,000-4,000. For example, Android open source project. So it is open source operating system of the Android. Or you might see some other options, for example, Yocto Linux, and you will need to download a bunch of the packages. And most of the packages would have master branch, and then new packages which were added recently to this infrastructure, let's call it like that, will have main branches. And then you will have a sort of pain, because you will need to keep track of what is the default branch, because it depends what Gerrit command you will use to send a new change, for example, to Gerrit or to the Git, for example. So imagine that we have a Git repository, it is our history, so we have empty init commit, it doesn't have anything, it's just empty commit. If you check the content of this folder, you might find .git folder. Usually it is hidden, so you don't see it, but you will find it in the folder with your project. And this folder is storing the whole information about your local repository. all your histories, all your branches, all your commits, and etc. So it stores everything, and it stores as well as a file references. The difference between Git and other version control systems is that Git, for example, stores file references or files. So imagine that we have added a new file and we added readme.md. So we added a new commit. Let's call it commit A. It means that Git will copy this file that we have committed, will calculate the hash of this file, mark it somehow, and link it to the commit A. So every time when we are editing a files and etc., then we call git status. Git is checking, is the file that we were working on was different compared to the reference that it stores inside the Git folder or not, related to that specific commit. In our case, it is commit A, for example. Imagine that we decided to add something new. For example, we decided to modify it to the readme.md, and we decided to add it as a commit B. Git will create commit B, but before creating commit B, it will copy the readme.md file and put it as a separate file, and will also calculate the hash of this file and link it to the commit B. By the way, the original one, the readme.md, which was related to the commit A, will exist in our system. And then we will have our commit B, or we will have the readme.md, another version, as a separate file. And it is quite important. Let me go to the commit C. Imagine that we decided to add git ignore in our repository as well. With commit C, Git will create third file, git ignore, and also hash it or make a calculation for hash and link it to the commit C. It is important to bear it in mind because sometimes people are thinking, oh, I will, for example, add in the commit B file, let me write it here, for example, file A, which has the size, let's say 5 or 50 megabytes. For example, and we'll commit it to the Git repo. And then say that, oh, I see that the size of the Git repository is quite big, and when I do git clone, for example, it takes a little bit more time. I will delete it. So when you call, for example, here, let's plus it here, like plus file, so we're adding the file, then minus file A, it means that you just mark in this commit that from commit C and no on, you will not have this file included, but file A will be stored in the Git. And every time when you will do git clone, for example, or you will copy this repository to remote one, you will still have this file A, which is 50 megabytes, because it's stored inside, for example, this commit or these references. It is important because sometimes people can create a commit and put, for example, a bunch of the files with total size, let's say 1 gigabyte, and then complain that the git clone works quite slow, but they have removed these files in another commit. It is quite important to remember. Okay, so that it is our Git repository. We know that we have a folder, we have a Git repository, and it stores information, and we have file references, and etc. A few seconds. So I would like to show you that I have created the empty project right now. It is called Awesome Project, and it has Jenkins file in it only. There is nothing else. And you can see that inside this project we have .git folder. It is not displayed in Visual Studio Code. It is displayed probably in File Explorer or any other file navigator that you're using. But internally you can see that there is like commit edit message, there is a config, description, fetch head pointers, there is index, packet refs, folders with branches, hooks, information, logs, objects, references. So all this information represents our Git repository. Sorry, maybe I phrased it in the wrong way, but all these folders and files in them are our Git repository, the local one. If you remove the Git folder .git from the Awesome project, it will become just a folder with files, and you will remove the whole history on your local repo. If you do something else with this folder and you damage it, or maybe you cut it and etc., you have a risk to damage your local Git repository. It is good to know. Now let's talk a little bit about the remote repository. Now let's talk a little bit about the Git remote repository. So as I said before, we have local Git repo. It stores, for example, .git folder with all references, files, hashes, indexes, branches. They are stored inside files. So we have in our imaginary project, we have git ignore and we have readme.md. As you remember, we had readme.md in the commits A and B, and we added git ignore in the commit C. When we create a remote repository, as you can see here, I added only this part, references, hashes, branches, and etc. And it is because in the remote repository, we are creating so-called bear. So we're using bear, and it means that instead of the storing the working tree, by the way, this part is called working tree. So the content of our repository that we are seeing on the browsing, for example, it is a working tree. So git ignore, readme file, or for example, folders with source files or any other files that we see in the repository itself, it is usually calling working tree. But then we have the content of the Git folder. And when we are initializing the remote repository, we are initializing it with bear to save the space, because usually when we are working with remote repos, we want to push or maybe pull some changes, but we don't want to have there the working tree usually. The difference between remote repo and local repo is that remote repo doesn't have any information about your local branches. As you know, it is obvious, but I just want to say that. Depending on the host system, it might be GitHub, it might be Gerrit, Bitbucket, or any other, maybe Microsoft Azure system or DevOps. Usually remote repository stores bare repository or this information about the references, hashes, branches, indexes, and then some, let's call it metadata. So it might be related to the access, for example, to this repo, who has access to specific repos or doesn't have repos, who has access to push to the master branch, and etc. And some other stuff if needed. And usually when we are working with the systems like GitHub, for example, or Bitbucket, or maybe GitLab, if we want to push our branch to the remote repo, we just call, for example, git push origin master or git push origin develop, and we are happy. We're creating a branch there and we do something else. It means that we are asking Git, which is working locally, to communicate to the remote repo and say, hey, I have a branch. Can you please create a copy of it to you? And every time when we do, for example, git pull or we do git fetch and etc., we're just sort of asking, hey, do you have any news for me? Is there any updates? And then we get an answer and we are either happy or we are sad because we have some issues. We are communicating with similar Git repository and we have the same structure. We have branches, we have commits. The difference in Gerrit, you might see that we do some strange command, which is, let me show you. Now, first of all, before explaining the Gerrit repository, I would like to stress one thing. One of the differences of the Gerrit repository and Git repository that you might see is that usually we are just cloning repository. If we are cloning it from the GitHub or maybe from the GitLab, we are just doing git clone and we cloning the repository. In Gerrit, we do it usually clone with commit message hook. We copy this long command that I pasted here and selected. What does it mean? As you can see, it is containing two parts. First one, it is git clone as usual, so there is no differences. And the second long line, it is usually entering into the folder with the cloned repository. And then, as you can see here, we sort of downloading the commit message and place it inside our Git directory. We need this commit message hook to generate the change ID. The change ID is one of the core elements, which is described in the user guide and in the walkthrough. So we have the local Git repository, which was cloned from the Gerrit, and we also copied message hook. So for example, commit.sh. It is called, or this commit message hook will be called when we are executing or performing the command git commit. So every time when we do git commit, this script is checking the commit message for the presence of the keyword change ID with some value. If we don't have change ID keyword, then it will generate change ID based on, I think, some input data, then hash it and add it into the commit message. It is still the same Git repo. It's absolutely the same Git repository as before, except that you have also commit message hook. We have our Git remote repo, or it is on hosting on Gerrit. So we have Gerrit repos. We still have our init commit. We have commits ABC. We have main or master branch, depending on the settings. And we want to push one of our commits. When we push our add or pointer to the current commit to the Gerrit, it will check, first of all, the parent of the commit. For example, it is based on C. Then it will check for the change ID in the commit message and will search, do we have any changes already created with this change ID or not? If this change ID is unique and it is not present in the Gerrit, database, then it will create a new change, let's say change N1. Based on parent commit C, it will have change specific number, for example, 2, 3, 4, and it will be based on the branch that we pointing out. So this is a change. Basically, it is our commit. So let me explain a little bit more. So we have our local repository, then we have our init commit, then we have ABC, and we want to work on something. So we have created the feature branch and we made a new commit, which is called, for example, D, and our Git commit message hook that we also copied will check the commit message and will find the change and will add the change ID generated with some number. Usually it is the hash or based on some input data like date. So we have our change ID and we push it to Gerrit. And you can see that we have init repository ABC. It is the similar like we have on our local repo because we cloned it. And it is creating the change number 1, let's say, and it is creating the patchset number 1 with the same change ID that we have in our local repo generated, because it was the unique change ID in the Gerrit database. And this change is our commit with the parent commit is C, so it is our parent. Now imagine that we want to, let's say, update our changes. So we modified our files and we made, for example, command git commit on our local branch. So usually we do some changes as usual with Gerrit and we call git commit. So we have in our feature branch 2 commits now, D and E. When we are calling git commit, since it is a new commit, then Gerrit commit message hook in our local repo will generate another change ID based on date and some other input data. And it will have absolutely different change ID. So when you will call git push origin head ref for master branch, for example, Gerrit will check this ID generated, this one. And since this change ID is unique in Gerrit database, it will create a second change 2 with patchset number 1, because the intentional changes that we would like to have, they have a different change ID. So it is important to remember, if you want to update your change, for example, change 1 with patchset 1, you want to update it according to the review, for example, don't call git commit or do git commit, for example, with 2 or 3 commits if needed, and then git squash. So you can squash these 2 commits into one, but keep this change ID, not this one. Then you can upload it again and Gerrit will recognize this change ID and will update your change 1 to the new patch set. That's why it is important if we want to do some changes or modifications, let's call it like that. If we want to do modifications in our files, in our commit based on the review, we do modifications and then we call git commit with option amend. Or, as I said before, you can add new commits to fix it and then call git squash. But important to keep this the same change ID as it was in change 1. In that case, when we will call git push origin head refs for master blah blah, then Gerrit will recognize this change ID, will compare the content of this commit and say, okay, so it is the same commit but with different content. So it is the same change for the review, but I will create the patch set number 2. If we take it a little bit shorter, the change is our set of the modifications that we want to push to the remote repo to have our end goal commit. What is the patchset? Patchset is the content of the commit that we want to push. Let's imagine that we have reviewed our change number 1 with patchset number 2. We got positive votes and we are ready to submit it. Base it on the configuration. It is important, I will repeat it again. Base it on configuration for specific repository. It can be either cherry-picked, and then this D commit with some specific hash will land to our remote repository and it will be D, or it might be merged somehow, or it might be rebased and merged, and then it will be a little bit different commit and it will be E, for example. Please pay attention for it and don't commit your files in the main branch. One of the good practice that I would recommend is to create a separate branch and work on it. Branch is better. Branch is easy to rebase, etc. I will repeat myself again and show the difference. For example, GitHub or GitLab or Bitbucket towards the Gerrit. So if we have main or master branch with init commit ABC, imagine that we have our feature branch. We want to merge it into the main branch, and then we have two options. Let me show you one of them, and it is merge strategy. So if we have just merge strategy, then what will happen is that our main branch or master branch, here it is our main branch, let's call it, will have init commit as it was here, ABC, and here we have exciting part. We merge the content of feature branch to the main branch. So we will merge these 3 commits, and this one is sort of transaction commit, which is indicating that we merged feature branch into the main branch. Usually you have it as a commit, which is called like merge branch, this one into the main. So, and we have 2 options. We have first one, it is just merge. So it is this option. Second option is squash. Squashing means that we take for example, our 3 commits. Let's call it as F, E, and D. So it is these 3 commits that we have. And we squash them into one commit. Let's call it as F2 quotes. So we squash this all modifications that we have done into one commit and merge it. Then we will have, for example, C, then we have here F, and then we will have G. So it is squash part. Here we have merge part. I just want to explain that if you have a merge strategy, there is the risk that if one of the commits are breaking some of the functionality of the project, then you might introduce a risk that somebody will clone the repo on that specific painful commit and will complain that the project doesn't work. So it is important. Now let's talk a little bit about the Gerrit. When we do Gerrit, and as said before, if we still have, if we still have Gerrit's change ID is the same. So imagine that we don't modify the change ID, we do git commit amend. Then we will just update or upload another patch set inside one of the changes. So it is our, let's call it D mapping. Here we have E mapping, and then we have here F mapping. So imagine that we reviewed our D commit, then we reviewed our E commit, which is breaking the functionality, figured out it, then we uploaded another patch set, it is our F. When we do here, as said before, git commit, then here push, then we have here git commit amend, then here we do git commit amend and push. So we will have paired patch set in the change ID, which is corresponding to the F commit that we have in our history. And once we merged it, then it will become, depending on the configuration, it will be either, I apologize, it is not exactly correct. This one should be F, or it might be G, depending on the configuration. If you have cherry pick, then it will probably take F. If it is a merge commit, or maybe it is merge if needed, a configuration that you might have G. So it means that you have a different commit hash. But what is happening, that the Gerrit has the same similar functionality as you have with the Git usual remote repo if you squash the commits, sort of. That's one of the difference between Gerrit and usual Git repository. Plus, you might see here list of the comments and reviews as well. That's what I would like to highlight. So, as I said before, we have already Gerrit repository, we have our awesome project, we will add a new file. As you can see here, I have added a new file, readme.md, in our... Oh, wait. So as you can see here, I am inside the awesome project repo and I call it git status. You can see that I'm on the branch main. So if I call, as you can see, in the git remote get URL origin command, I can see that it is my local Gerrit instance for the awesome project. So it is new file readme.md added. So let's add it into the commit, or it is not our commit, it is staging area. Staging area is some buffer in the between of git history and working tree. It is a little bit interesting place. I would strongly recommend to read pro git book, so you will understand a little bit better, because they have really good explanation about it. So we added our file to the staging area. So we check it and you can see that change to be committed. Now let's add the commit. So we committed and we call our commit. Let's write here add readme.md file. Save it. And you could see that I used just one line, add readme.md file. But now look at this. If I call git show add, you can see that commit message hook, which was added inside awesome project, has generated the change ID. So it is important. Now I will call here git push origin head refs for main. This line you can read as, so usually I am reading it in the following order. Git push origin head refs for main. Git please push into the remote repo, which has an alias origin. So it is some local host, it might be some cloud instance and etc. But I have this alias origin. I would like to push my commit, which is selected by head pointer. In our case it is commit in the main branch. And I would like to push it for the references towards the main branch. So I would like to create a new reference for the main branch. So I call it, and you can see that we have pretty similar commands as git usually, except the new file thing. Process changes, reference 1, new 1, success. You can see the link to the change with title, status new. So if we following by this URL, or if we navigate to Gerrit, you will see that we have a new change, readme.md, we have owner, we have here change ID and etc. So according to the page, we have our commit in the separate branch. Now let's imagine that, oh, wait a second. It is good, yes, but I would like to have it a little bit differently, maybe with new line in the end. It is a little bit bad example, but let's just play around. So we go to Visual Studio Code and we go to readme file and write here indeed. So not that informative, but at least some change. And imagine that we forgot about it. So we call it here git add readme as usual. Then we do git commit and I just creating a new commit. Let's call it update readme.md, right? We save it. We have a new commit. So look at this. If I do git show, you can see we have another change ID compared to the one that we have before. We have small change still, and we think, okay, that's fine. If we check the log, you can see that I created the first commit and change and second one as usual, right? So now I call the same command, git push origin head refs for main, and oops, I have a problem that I have created a new change. You can see the status new. It is not good. If we open the Gerrit, and you will see now that we have the second change, update readme, because ID is different and you see the relation chain. It works sometimes if you have depending chains and you want to make them as a separate changes, but imagine that you have 100 updates that you will need to do, so you will have technically 100 commits and then it will add technically 100 changes new, so it will be bad. How to fix it? So one of the options will be to choose one of the changes that you would like to keep. For example, I know that change number 22 is not needed, and I would like to use 21 because it was, for example, reviewed by, let's say, by someone. So we have +1, we have, for example, some reviews. So I would like to do that, abandon this change. Abandon change, obviously, you're just mark it as not needed, and then Gerrit will not show it to anyone else for the review. So for example, it was created. It is good to leave a message because sometimes you don't know why the change with some modifications were abandoned, and then it is good to mention it. What is the reason? So we abandoned it. Now we update it. You can see that we have the change. It was abandoned. Nice. So how to move these changes into the first one? Relatively easy so far. We open our code. We do git log. We see that we have 2 commits. So we would like to combine them together. Usually what you do, you type, for example, git rebase interactive, and then we need to mark the commit, the one commit before commits that we want to modify. So we want to modify these 2 commits and squash them together. So we pointing to the third one. So we are type here, for example, cat 3. We call the git rebase. We specify interactive options, and we specify 3 commits. So we want to work on these 2 commits that we have, plus 1 before them, to have sort of anchor commit to navigate. So let's call it. You can see that we have list of the commits with the keywords pick. Here you will find explanation about it, and our idea that you can see here, squash commit, use commit but meld into the previous commit. That's what we want to do. We change pick here and we type either S or squash. Usually I use the full name just to avoid misunderstanding. So you can see that we want to keep our third commit as usual. We will use the first commit that we made with change ID. As you can see here, the reference commit that was before our 2 commits is still there. We want to keep the first change, the first commit, but we want to modify the latest one that we have made, and we want to squash them. We save it. And now you see that we have 2 messages. Here I would recommend to double check the change ID that you have in the original change. For example, here we want to keep the change number 21. We remember that we have this change ID with 20D in the end. Remember it. We have the title add readme md. We go back to the console. We see that it is our maybe I can use these lines. And we simply modify the commit message. In case if you accidentally removed the change ID and you don't remember what to type, you can always go back to the Gerrit and just copy paste the line change ID and keep it. You keep the title, maybe some description, and change ID. Save it. Now you see that it was successfully rebased and updated. So if you call git log now, you see that we have our original commit that was before us, and we have only one. It is different commit hash, but it is the same change ID. So if we now send it again to the Gerrit, we still have the same change ID. Look, you see that we have success, we have the same change ID 21, and we got even the messages that unfortunately, but all our approvals were outdated and were removed. Let's go to our Gerrit, and you see that we have change 21, we have Patchset number 1, it was our first commit. We updated and we see that we have now Patchset number 2, so it is the content of our modified commit. We have code review 1 and etc. So now what we can do, we can just set, for example, code review +2, and we want to submit it. Interesting part, we press submit, let's call it done, we are saying commit, yes. So it is submitted, it is merged. You can see that the message is change has been successfully merged. In some cases, you might see that change has been successfully cherry-picked or something similar. Maybe commit was cherry-picked and etc. It depends of the repository settings. You can always check it if you navigate to the project itself with the page when you want to browse or you want to view changes or you want to download. In the configurations, usually you will find in the repository options submit type, and here depends on the configuration. You might have merge if necessary, you might have fast forward only, you might have rebase always, rebase if necessary, you might have merge always or cherry pick. So it depends of of the configuration. You can always check. But if you go back, so 1 second, since I messed up things in my configuration, you can see here. So if I call git fetch, and now I type git status, it is good that git log origin main. As you can see here, it is quite good that the hash of the commit is the same. Otherwise, I might ended up with a message that my branch and remote branch are diverged. So I need to remove my commit message. It is just a small thing to working with the Git remote repository. So that's it. That is the flow that I would like to show you about the Gerrit. So the most important part in the Gerrit, if we are talking about it, is our change ID. If we want to upload some new patch set. And for example, if we're talking about set of files, you can see we have base. It is the reference branch towards which we want to apply modifications. Then we have our content of the commits that we uploaded as a patch set number 1, patch set number 2. So if you want to see the difference, if I click on the difference, right, and I choose patch set number 1, you see that I have the file added, so new file mode regular, I have the message, and now I have patch set 2, and it is updated commit with new line. And also I can check the difference between our patch sets that we have uploaded. What was the difference between two commits that we re-uploaded or re-applied? It is a little bit confusing, especially with patch set changes and modifications. So that's why I'm trying to use word modifications, not changes, to avoid mixing of our actions and content inside the Gerrit. So we have covered the change, we have covered reference and patch set. Pull request vs change. Basically, in our case, we mostly refer to the review part. So in Gerrit, we are reviewing changes. In GitHub or GitLab, we are reviewing pull requests. In both cases, we see the source files. The difference is, let me show you. So the difference between GitLab or Gerrit. So talking about the difference between pull request or merge request versus change. Imagine that we have our feature branch that we want to merge into the main. So in GitHub or GitLab or Bitbucket or some similar system, we will create either pull request or merge request, doesn't matter. But we are saying that we would like to merge this branch, feature branch, into the main. And then we have review or approval, and we have some comments. We can add new commits if needed. With some updates and etc. And in the end of the day, we will have two options, either merging or squashing it, but it will be ended up in the main. So with Gerrit, we usually have changes, and change contains different patch sets. Change might be for usual file modifications, like add, new, delete, and etc. Or change might contain also branch modifications, for example, rebasing it on another branch, merging one branch to another, and etc. Because it is also some sort of transaction that I want to move from this state to this state, so it might be a change. That's an idea. So Gerrit stores changes. GitHub, GitLab, Bitbucket uses merge requests, pull request, or something similar. Now let's talk a little bit about the voting system. As you can see here, I have only code review label. In some cases, we might have code review and verified label. Sometimes you might see even more, like code review, verified, tested, and now approve it. You might have different set of labels, and it is usually configured in the projects on the Gerrit. So I will show you one thing. So usually projects are inherit all settings from one root project in Gerrit. It might inherit settings from all projects, and it might relate to the access, it might relate to branching strategies and some other stuff. And one of the things in the Gerrit, what Gerrit stores remotely together with projects, it is specific branch. It is called meta config usually, and it stores information or configuration for the projects. What is the description, how to submit it, as you can see here, access to different so-called branches or different parts of the repository. And also it stores information about labels, for example, access to these labels, and also labels themselves. For example, code review, what is the function, default value, and copy condition, some other stuff. Here you have configuration for these labels. If they are configured correctly, then you will have it on the Gerrit. So it is quite difficult to say for absolutely all projects or in absolutely all instances what is the configuration. Quite often you might have that for some projects you need to get only code review +2 and then be able to merge it. In some configurations you might have, for example, settings that you need to get +1 and it will be enough to merge it. Under +1 I mean the code review. In some configurations you might have code review +2 and verified +1 and etc. So it depends of the configuration of Gerrit for that specific company. That's what I would like to cover about the voting system. One thing that I would like to cover is the topic. Imagine that we have, for example, 2 or 3 repositories and they are linked between each other or they are depending on each other at some point. For example, project A depending on project B. And we would like to upload changes for both repositories, so we will have 2 changes, and we know that should be merged in the same time together. They should not be merged like one by one. How to solve it? You can create 2 changes and write for both of them topics. They should be the same topic name, so it should be the same either keyword or the same sentence. Then Gerrit will understand that you have 2 changes with the same topic, and even you get +2 for both of them. It means that Gerrit will allow you to send or submit changes together by one click usually. I will try to show it in the separate video most likely. So imagine that I have created a change to share with one of my colleagues, but it is not ready yet to be reviewed, let's say. So how to mark it for others that we don't want to review this change yet, so we are working on it. Quite often you have in the options mark as work in progress. So you have the title work in progress. If you open the dashboard for changes, you will see that you have demo changes and work in progress quite often. If you open the list of the changes for Gerrit for specific project, you can see that quite often you have this filter is not work in progress. So you can remove it and you can see that you have a change with the status. Quite often it is nice to have it because imagine that you open, let's say, a list and you have 20 changes, but 18 of them are work in progress. So you don't need to be scared. You just need to enable this filter and review 2 of them, which is nice. You don't need to have to go through 20 of them. So that is a good thing. So it is one of the things to hide your change from dashboard and not be reviewed if you want to continue work on it. Once it is ready for the review, you can call it as mark as active. Another thing that you have, imagine that you are working on something and you don't want to show it to anyone else, but it is your private work, or let's say your proof of concept. You have some code that you are not ready to show to others. In that case, you can go and mark it as private. If you mark it as private, then only you and list of reviewers might see the change on dashboard. So it will be hidden from anyone else, except people who are owner and reviewer, and probably committer as well. So if I go back to the open, and you can see private status, and this change is only visible to its owner and current reviewers. So it is important, remember. So if you want to not show your change because you are working on something exciting, or it might be not ready to show anyone else, and etc., you can always mark it as private. And once it is ready, you can unmark it as private and it will be active. So it is 2 things that I would like to cover. How to imagine that we would like to, one second. So imagine that I created a change, I modified the readme.md, and you can see here it is modified. I'm in a custom branch, custom change. I would like to create a change and I would like to mark it as, for example, work in progress. That's quite easy to do. So I committed first. So I modified the file. I added it to staging area, committed. Now I have this commit. You can see there is. I am in the custom change branch and I want to upload it. And let's say I would like to mark it as a work in progress. I type the usual command as usual. So git push origin head refs for main, but in the end I'm adding percentage symbol plus VIP. It will be work in progress. Or I can type here private, and it means that I want to mark it as private. So I think that it is even possible to mark it as VIP as well, like that. Let's experiment. Otherwise, I will be just reject. So yes, unfortunately, it was just ignore it part. Maybe I can do here VIP. Okay, sorry for that. Let me show you. So I have committed the change. You can see it here. It is custom change. We have commit, we have change ID. That's it. So now I want to upload it to Gerrit, but I would like to send it as private, for example. And in order to do that, I call the command git push origin head refs for main. Then I add %sign and then type private if I want to upload it as private. Or I'm typing here VIP and then I will upload it as VIP. So here I'm typing VIP and send it, and you can see that it was successful and added here the VIP status. A little bit earlier I typed accidentally git push origin refs for main private and it was created as private. So let's go to the Gerrit and I will show you what happened with the changes. I will remove here this filter. So I have two changes, workaround. One is VIP, one is private. And it is because I used the commands, or I used here this argument like VIP. I think that there is a possibility to specify work in progress and private, but to be honest, I forgot how to do that. But you can always check on the internet how to do that. But quite often you are using one of the options, either work in progress or private. Another good thing that I would like to show you is the REST API. The REST API is quite interesting functionality. It is useful in case if you would like to communicate with Gerrit through, for example, Jenkins, or maybe you would like to write some script to communicate with Gerrit and, for example, get list of the changes, or you would like to get list of the projects and write a script which will create projects for you by some simple command and etc. So I would recommend to check it as well. It is quite interesting to play around. In changes, for example, you can get a list of the changes, you can create one, you can query changes, you can abandon them, you can comment them, you can set labels for them, mark them as a work in progress, etc. It is possible within the script. For example, if you are writing a script for the Jenkins, you can write the functionality which will be based on linters. We'll call commands towards Gerrit to mark specific file, specific line. Yeah, I think it is specific line, that's it. You will mark it and will add the comment. So it is quite cool, but it is for the REST API. If you are interested in the communication with Gerrit, you can try it out. It's quite cool stuff. Another thing that I would like to cover, imagine that we have our awesome project, some project we call browse, and we see that we have here branches, and we would like to know a little bit more about this repo. It is quite interesting hack, if I can say so. If you click on the main, you have here awesome projects refs head main. So if you modified it for refs meta config, you will open configuration for this particular project, and here you can usually see how this project is configured, or this Git repository is configured. And also, if you have an access, you can add additional configuration for it. It is quite useful in case if you have a task to add additional webhooks, or you need to configure a plugin for specific repository, etc. So here in the project config, you see that almost everything is inherited from all projects. So you know that if you want to know access for this particular project, you should check all projects and etc. Because sometimes you might have a little bit complicated settings for the access, or maybe for some other plugins, and you can check this refs meta config branch. This branch stores information about access from Gerrit. One thing that I would like to add as well, it is depending on the configuration, but if you have, for example, I think it is called SAML configuration. So in case if you have SAML configuration, I think this picture is better, or you have some authentication through Windows, or maybe some other authentication tool, you might end up with the situation when you log into the Gerrit, let's say by using Microsoft account account or any other specific account, but not the Gerrit one. So you don't have actually the password for the user. So if I click on my demo instance sign out and I want to sign in, here I'm typing username, email address, account ID, and then for example a password. Here, since it's a demo setup, I'm using one of the predefined accounts. In case if you don't have any page with login and password, but you have, for example, authentication through Active Directory or Microsoft authentication or any other authentication page, and you landing as a developer, so then in case if you need to configure your profile, I would recommend you to check the settings. Here you will have your ID, email if needed, then your SSH key when you can add it, of course, and then here you will find HTTP credentials. If you need to get an access to REST API, or you need to, for example, use HTTP downloading. So imagine that we have, for example, our projects we want to download and by using HTTP. Then Gerrit will ask you for a password. For these purposes, you can generate this new password and you will get it. If you need to use HTTP credentials, such as password, for example, you have your user. Password will be generated, but please be careful because every time when you click generate a new password, you will get new password. The old one will be removed and it will be shown to you once on the small window. Then please be careful and save it somewhere. You can save it somewhere locally, but please be careful. So it is to use HTTP credentials, for example, to clone repository by using HTTP protocol. Then you will need to generate this password and store it somewhere. That's what I would like to cover for basics about the Gerrit usage and what is the difference between Gerrit and other Git repository. Thank you so much for your time and your attention.